our next class will be demonstrating the access modifiers, which we've already identified. Bank account. Right? So bank account's fairly straightforward. We are going to create a new class. It is going to have a bank account has these following attributes. Let's say it has a double balance. That's how much money currently it can have. It has an int, not an int, but maybe a string owner, right? So who owns the account? Maybe we'll just call it name, right? The name of the person on the account. What actions can we perform? Let's go ahead and do a public static, not public static, but a public void deposit, right? And a public void withdraw. And both of these are going to take in a double. And so these are the actions you can perform on a bank account. So you can deposit some amount of money, double X, so double amount, and then you can do double amount as well. So public void deposit, public void withdraw, a certain amount of money. Okay. And let's go ahead and create our constructor for it. Here we're going to go ahead and create a public bank account, and we're going to make the constructor with two variables, which are the double balance, which will be the starting balance, and the name. So what we'll do is just simply do this dot balance is equal to balance, and this dot name is equal to name. So we're able to initialize both when we are given a balance and a name. And suppose maybe they only supply a name, public bank account. And what we can do then is that if they provide a name, right? This dot name is equal to name, but they didn't provide, say, a balance. We can give it maybe a default, like maybe you need a $50 minimum. So, okay, that's enough for right now for us to demonstrate the point of this exercise. So let's go ahead and make a bank driver, PSVM, bank account, Alice account, which will be for Alice, is equal to new bank account. And let's say Alice has again, this is for Alice. Oh, wait. No. We want 100, and then who owns it? Alice owns it. Right. So it's pretty straightforward. We can also, let's go ahead and write a public void print this method. We'll find a better way to do this later on. Again, this is just incremental complexity. Print this dot balance. This is what we're going to do over here. Sout balance. So let's say name plus apostrophe s account or balance /t, and then plus this dot balance. And it's fine for me to use this dot in one place and this in another, except for the fact that you should probably be consistent. So we can then go over here and say Alice account dot print this, run it. Balance is 100. Right? Now we can increment our balance, right? Dot deposit 500. So let's go ahead and complete these because we didn't write them. And all that should do is go this dot balance plus equals. So we should increase it a certain amount. Plus equals amount. And withdraw should be this dot balance minus equals that amount. So now if we go back over here, deposit 500, Alice account dot withdraw 100. So that was 100 plus 500 minus 100. So the total amount should be 500. Run this and we get 500. Makes sense so far. Okay. However, so what does this have to do with access modifiers? Well, the premise is that ideally, if you were writing something that's sensitive like a bank account, I would like you to only interact with the bank account in certain ways. Specifically, I'd like you to just use the behaviors, the deposit and withdraw methods, and the print this method. I don't want you to be able to do this. $100,000 million balance. That's thinking small. It's weird. So now Alice's balance is equal to 10 to the 16th power, right? Because I have access to the balance variable. So that means I can do anything I want with it. And this is somewhat of an issue. This gets into a concept called encapsulation. Basically, if we reveal all these things to our user, one, they can use. If we reveal all the features of our program to a user, they can manipulate them in a way we don't want them to. The second is the more we reveal to the user, the more complexity they have to deal with. So if we only want them to basically use the constructors, the deposit and withdraw, and the print this, then we should be explicit about that. So there are 4 access modifiers in Java. There's public, private, protected, and blank. Right now, our instance variables are blank because they don't have anything in front of them. Blank means that we can, in essence, everything in this project can use them. Here's a bit more of exact definition. You can check your book for it. But in essence, everything in the same package can access it. So that means that as long as I'm writing code in here, no worries. If it was public means anybody can use it. That means now anybody, including people outside of this package, outside of this project, can modify it. That seems a bit insecure. So what we're going to do is that we're going to close this up. So how do we solve this problem? Well, what we're going to do is we're going to use the opposite of public. We are going to use private. And now that means that we are going to private name balance here. Oh, sorry. This should be a string. So now, by making it private, if we go over here, notice that we get an error. Balance is private. It has private access, meaning that we can't modify the balance. The only way we can modify balance is by using the deposit or the withdraw methods, which we could possibly put restrictions on, such as limiting the amount we could deposit or we could withdraw, right? If amount is greater than this amount, then we need to flag it. If we withdraw and we're going negative, then we need to flag it, right? So there's all sorts of things we can add on here, but because it's private, I can't do this. Alice account dot name is equal to whatever because name is now private. I can't use it. Methods can also be private. We sometimes refer to these as helper methods, which are methods that just exist inside of here to basically help keep the code clean and organized, or to help us implement something like recursion. So it's possible for anything that you see over here to be public or private. You might be wondering, what's the use of a private constructor? Well, we actually kind of saw that earlier, right? You can't create a new math class, right? Again, math is a bunch of static functions. They don't need any instances of the math class. There's no point in writing a new math. So if you want to prevent somebody from making any instances of your class at all, you just make the constructor private. And that'll prevent them from doing so. It's a way of controlling access to certain points in your program. So let's go ahead and take a look at our point driver now that we make these two things private. And actually, I believe because of the way we've modified things around, we don't need to change anything in here. But, okay. With our point object, right? What if I want to actually want to change the point? I want to change x maybe to be, and the x and y to be 5, 5, right? What if I want to change it to be 5, 5, right? Should I make these public? Allow anybody to change them? And the answer is that our convention is that we make all of our instance variables private. If we want to allow our programmers to change things, then we use special methods. It also means that I can't do something like this, by the way. p1.x. I can't print it out like that. It's private. Can't see it like that. And again, if we want to be able to see it, we're going to write a method to do that. This is the concept of encapsulation. We always keep these private unless we have a good reason not to. And even then, the best way to do things is to write special methods called accessors or mutators, but nobody calls them that, certainly not me. And we instead use the term getters and setters. So if we notice over here, right? In fact, if I go, I think it's Alt Insert to do over here, generate, not point driver, but in here, Alt Insert, generate getters and setters. You can also generate constructors using an IDE. So what does a getter look like? Public, it was even suggesting it to me. Public int get x, return x. That's all it does. A getter simply gets a variable and returns it to you. Public int get y. So if we want the user to see what the y is, return y. Notice that this can prevent them from because of this, because x and y are integers, they can't really change those things. If x and y were arrays, they could change the arrays because we'd be giving the memory location of that array. But for the most part, with getters and setters, a getter means it's read-only, and a setter like this, public void setx, means it's writable. And this is just the convention we use in Java, using getters and setters to set specific variables.